Hello and welcome. In this video we'll be doing this question and it's probability. So the first part here, it's grade 11 probability, and I think you should be familiar with this. It's the table of contingency, right? Or the contingency table, right? So let's look at the question, right? So in a survey, 1,530 skydivers were asked if they had broken a limb, right? So the result of the survey was shown as follows, right? So we can see this table of contingency here with the information here, and by the looks of things, this is a table of totals, right? So I think you can clearly see that this is the male, right? So we have like male who are broken a limb. It's the number it's 463, right? So the number of the males who are not broken a limb, it's B, right? So we don't know the number of the ones that are broken, but we do know the total, right? So if we know the total of the number of males in that survey, we can work out the number of those that are not broken the limb, which is this B value over here, right? So as much as we are looking at the broken limb here, this is the males that are broken the limb, which is 463, and looking at the females, we don't know that are broken a limb, but we know that the total of those females, so the total of the people in the survey is 916 that are broken a limb, right? So I think we can work with this and do some subtractions, some necessary subtractions to work out the missing values, right? So let's get straight into the first question here. So 5.1, calculate the values of A, B, C, and D, right? So 5.1, I think you can clearly see that to work out the A value, we can simply say A is equal to the total of those that are broken the limb, total of those that are broken the limb minus the males. So we are looking for the females that are broken a limb, so we'll just minus the two numbers, and if we do that and we use our calculator, 913 minus 463, we can see that the answer is going to be 450. So let's go and look at the value of B quickly. So the value of B, so this one is 450. We've calculated this one. The A value is 450. So let's go and look at the value of B. So the value of B is going to be the total 782 minus the 463. So we are minusing the total of the males with the ones that are broken a limb to work out the ones that are not broken a limb, right? So it's not as difficult. We're just gonna do some necessary subtractions here to work this out, and the value for that, it's going to be 319. So let's quickly go and write the value that we got here, the B value. The B value is 319. So now we can work out the value of C, because we have the ones that are not broken a limb. We have the males, but we do not know the females, right? So we can still work that out from the total, right? So C, it's going to be 617 minus 319. So 617 minus 319, the value is 298. So we have gotten the value. We go and write that value on the table, 298. So now we have as much information as possible. We can work out also the D value. So the D value is going to be as easy as 1530, which is 1530 minus 782, right? Someone can work this out by adding the two, the A and the C, to get D, right? And I think in terms of expectations, we should get the same answer. So 15, so 1530 minus 782, it's 748. So we can just also confirm if the 450 plus the 298 gives us that answer. And I think, yes, it gives us that answer. So it means that we've done this correctly and the table works perfectly fine. So let's move on to 5.2. So we have to calculate the probability of choosing a random, at random in the survey, a female skydiver who has a broken limb. So let's go and take a look at the females. So the female category is over here, right? And we're looking specifically at the one that is not broken a limb. So not broken a limb, the intersection there is 298. So the probability of female and not broken a limb it's simply 298. This is the number. So the number is 298. The number of those females that are not broken a limb, it's 298 over the sample space value, which is the 1530, right? So which is 1530, right? So we can move on to the next question, 5.3. So is being female and having a broken limb independent? So to look at that, we will go and look at the probability of the female. So we have to choose two categories that we're going to work with here, right? So I think we can just choose the ones that are given here. We're going to choose the category of females, which are skydivers, and we will look at the ones that are broken a limb, right? So we just want to check if those two events are independent, right? So let's first write down the probability of the females. So we'll first look at the probability of the females, and I think we know in mind that we should be able to notice that the word independent, the end of the two probabilities is supposed to be the times of the probabilities, right? So this is what we're trying to test. So we'll go and look at one category, which is a female. So what is the probability of the female? So the probability of the female is this value we got here. So let me write the value down, the D, which was 748. So the probability of the females, it's 748 over 1530, which is the sample space. So this is the probability of the females, right? Regardless of whether they're broken a limb or they're not broken a limb, we're just looking at the probability of the females, and that is the value, right? So let's go and take a look at the probability of the broken a limb, right? Which is the second event we have here, right? So let's look at it. Broken a limb. So the ones that are broken a limb, it's going to be 909 and 913. So I'm not specifically looking at the female. So I'm looking at these two events separately, right? The female one, which is this one we got over here, and we went on to look for the ones that are broken a limb, right? So which is going to be 913, regardless of whether that it's a male or female. So we're just strictly looking at the ones that are just broken a limb. Then we write the total number, which is 913, over the total number of the sample space, which is 1530. Right, I think you guys can see what I'm trying to do here, and we can now take the two numbers, the probability of the female, we want to multiply. So we get those probabilities separately, we multiply them. So the probability of broken limb, I multiply with the probability of the female. So this is going to be 748 over 1530 times 913 over 1530. So let's quickly go and multiply that to see what is the answer, and we will compare the answer with the intersection or the end of those two probabilities, right? So the answer here is going to be 1530 times 913, 1530, right? So 1530. So the answer here is 0.2917 and whatever. So now we can quickly go and look at the intersection. So let's take a look at the probability of the female, probability of female and broken a limb. So we want to compare the end and the times, right? So if the two gives us two values that are the same, then it means that the events are going to be independent. Sorry about that. So we're going to look at the intersection, right? So let's go and look at the intersection between these two events, right? So we want the broken limb and we need females. So this is 450. So the answer over there, it's going to be 450 over 1530. So what is the answer? The answer for this is 1450. It's 450 and 1530. The answer, it's going to be 0.294 and whatsoever. And I think we were encouraged to round off to two decimal places, and I think if we round this off to two decimal places, the answers are going to be the same, right? So if the answers are rounded off to two decimal places, we've got 0.29 here, and we also have 0.29 here. So 0.29. So I think since the two since we have the probability of the end and the multiplication the same, then it means that the events are independent. So they are independent. From these calculations, the answers are the same. So if you see that the answers are the same, then it means that the events are independent, right? I don't think the limb getting broken and the gender, those two are dependent. I don't think so, but you can also do your own workings and you will see how we can do this. I hope you guys understand how to sort of work these things out, and you will sort of enjoy these calculations when they ask you the questions. Two events are independent because the probability of the female and broken a limb, so I'm just gonna write like this, is the same as the probability of a female times the probability of broken a limb, right? So I hope you guys understand this, and I will just give you guys a few minutes just to take a look at everything that we've done here. So if you don't mind, you can, if you were not writing, you can take a screenshot of this, because I just want to quickly erase this to create space for question 6, right? So you can take a screenshot over there, and you can also take one for this part. Yes, and I think it's perfectly fine there with that question. Then we can quickly move on to the next one without wasting any more time. So I will just erase this. So just quickly erase this part and just create space for the next question. So yes, now question 6, what we have to do here is to read the question, understand what the question is looking for, right? So question 6, there are 7 different shirts, right? And 4 different pairs of trousers in a cupboard, right? So the clothes have to be hung on the rail, right? So 6.1 question, it's asking that in how many different ways can the clothes be arranged on the rail, right? So let's go and take a look at the 6.1 question. So how many in total? So I think we've got like 11. We've got 11 items. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So we have 11 items, right? And they're saying that in how many different ways can the clothes be arranged, right, on the rail. So just take a look at what would occupy the first one. So I think because there are no restrictions and there's nothing here, any of the 11 items can occupy this space. I hope you guys understand me. So I'm taking a look at the simple space that can occupy that space, the number of items, possible items that can occupy the first space. So it's any of the 11, and because now 1 has already occupied that, I'm just gonna say 11 minus 1, and the answer is 10. So it's any of the 10 that can occupy this space. You see that? And then if you can look at the third one, it's because now because 2 items have already occupied the first space and the second space, so any of the 10 minus 11, which is 9, can occupy the second space. And without the waste of time, if you guys can look at the trend here, you can see that it will keep decreasing by 1 number, by the value of 1. So this one will have 5 items that can possibly occupy this, any of the 4, any of the 3, any of the 2 items, and that last one will just occupy that last position, right? So I think you guys understand this, and if you can write this in a summary, it's just 11 factorial, right? So the 11 factorial on the calculator, you press 11, then you will say equal sign, you'll press 11, shift, there's the exclamation mark somewhere there on the calculator. It's just underneath the mode button. So it's going to be a very big value, 339,168,000, right? So that is the answer we got for that, and it's like 39,916,800, right? So I hope you guys can see that value over there. So 6.2. We can move on to 6.2 question without the waste of time, and saying in how many different ways can the clothes be arranged if all the shirts are to be hung next to each other, or next to each other, I think it's supposed to be next to each other, and the pairs of trousers are to be hung next to each other, right, on the rail. So we can now proceed and take a look at these. One, it's not going to be as easy as the first one, of course, so we can create those 11 spaces here, 1, 2, 3, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So look at this, we have got 7. So 7 items must be here. They can be, we can have like the shirts on the first 7 spaces, then we can have those ones on the last 4 spaces, right? Because they should be together, they should be next to each other, right? So if you take a look at the first one here, the first the number of items that can possibly occupy the first position, it's any of those 7 shirts, right? So any of the 7, and because now the 7 has already occupied that, I'll say 7 minus 6, sorry, 7 minus 1, right? Because one item has already occupied the first position. Now I'll be left with like any of the 6, then I can put it there. Then I can say on the third one, it's going to be the 6 minus 1, which is 5. So any of the 5 items can occupy this space, and any of the 4, any of the 3, any of the 2, and 1, right? So I think you guys get what we're trying to do here. And taking a look at the second part, which is here, the first one here can be any of those 4 shirts, right? So you can put any of those 4, and because the 4 has already taken that space, the second space, it's going to be 4. So because 1 has already taken that space, any of those 4, we just minus 1, and the answer is going to be 3. We'll write 3, and then 3 minus 1 on the third one, which is also 2, and then 1, right? So taking a look at these arrangement over here, I just want to erase the part down here. This, in summary, it looks like 7 factorial. So because this is part of grouping, you can agree with me that amongst the groups, we can have the shirts being the ones starting here, right? So we have OR here, right? We have, if I can write this is 7 factorial times what? 4 factorial. So if you take a look at it, we can have the 7 factorial on the first part, or we can have the 4 factorial being the first ones, and the 7 factorial being the second ones, right? So looking at this, so this is like 7 factorial times 4 factorial plus the OR, you know, that is associated with the plus. So the OR, we can just say it's a plus. So if you look at this, plus 4 factorial times 7 factorial, right? So if we add the 2, we'll see that the 7 factorial times 4 factorial plus 4 factorial times 7 factorial. I think the calculator does its bottommost, and I think it will give us an answer for this and an answer for that, which someone would have just said 2 factorial, right? Yes, and I think the answer here, it's going to be 241,920. Yes. So yes, I think that's the right answer, 6.3. Let's move on quickly without the waste of time. What is the probability? What is the probability? I'm not asking for the number, but I'm asking for the probability that a trouser will be hung at the beginning of the rail and the shirt will be hung at the end of the rail, right? So let's go and have a look at this one. It's going to be a little bit interesting because we'll also consider the probability, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 11 spaces over there. So taking a look at this, it's specific. It's saying that on the first one over here, we must have the trouser, right? So I think we've got like 7 trousers, if I'm not mistaken, right? So the fact that we've got 7 trousers, and taking a look at the last one here, we have like 4 shirts. No, sorry about that. Let's quickly just go back and take a look at that. We've got 7 shirts, right? Sorry about that. So it's 7 shirts. So the shirts, it's the number, it's 7. And then the trousers here, we can look at the trousers. We've got the trousers, we have got 4 of them, right? So let's take a look at what could possibly occupy. How many options do we have for the first one? For the first one, we have strictly seven options. So we're not going to have any more option. It's only any of the 7 sheds, right, that should occupy the first. Oh, I think they're saying the trousers, right? So the trousers should be here, so it's going to be 4. So let me just rearrange this. So what is the probability that that a pair of trousers, right, meaning that my trousers must be here and my shirts must be at the last, right? So it's 4 of those and it's 7 of those, right? So I'm just gonna quickly put 4 here and the 7 at the last, right? So how many trousers? 4 trousers. So it's any of the 4 trousers that can occupy this position over here, and you will agree with me that is any of the 4, right? And the shirts, how many shirts do we have? Any of those 7 shirts can occupy that position. And I think there are no restriction, there's no any other restriction after this, right? So they just want the t-shirts to be hung, the trousers to be hung on the first rail and the shirts to be hung on the last rail. So 4 possible options that I have for the first one and 7 possible options that I have for the last one, right? After that, I'll have like 11 minus 2 because it's already 2 spaces that have been taken there. So I'll be left with 9, and I think any of the 9, any of the 8, because now the number will just keep reducing by 1, 4, 3, 2, and 1, right? If you take a look at this, it looks like I've got 4 times, and because this here I can write in summary, it's just 9 factorial, right? So it's 9 factorial times 7. So these are like numbers, so these are not like factorials, right? The last ones is like 4 possible combinations I can have there. The factorial, it mainly means that it's when you summarize, like when you start from that number and you're multiplying until 1, right? So these are just gonna multiply here. These numbers are just multiplying, and these ones are also multiplying, right? So the factorial is just the summary of the multiplication, right? And I think this is your answer, but you must just put this over 11 factorial because you want probability. So the probability of that, it's going to be 4 times 9 factorial times 7, and the answer we divide by 11 factorial. So the 11 factorial is the sample space, and I think the answer is going to be 14 over 55, which is 0.25, right? So this is the probability of that, and I think it's perfectly fine there. And if you follow from this video, there's a lot that you can learn, and maybe these ideas are going to help you in future when you approach your exam questions. And I think it's perfectly fine there with this video. And thank you, and goodbye. See you in another video.